During the first 6 months of 2020, canny investors sunk an astonishing $35 billion of their hard-earned loot into forthcoming offshore wind projects, and several similarly eco-friendly schemes have been greenlit since. So now wind power has apparently overcome most, if not all, of its skeptics. The question becomes, what kind of awesome new tech is all that money being blown on? Join us today as we take you for a spin and show you round the world's biggest wind turbine. General Electric's all-new Haliade-X is an elegant marriage of form and function if there ever was one. Rising gracefully some 260 meters above sea level, each is capable of generating at least 12 megawatts of energy with an impressive industry-leading 63% capacity factor above industry standard. That means when fully operational, the Haliade-X will be capable of churning out 67 gigawatt-hours a year. That's 45% more than the most powerful and efficient windmills operating on the market today. Capacity factor, since you ask, is a metric that compares how much energy is actually generated over a given spell compared to the maximum that could potentially have been generated during that same period. It's a mathematical wheeze that essentially prices in weather variability, a major factor in wind farm development. Obviously, in an ideal world, the wind blows consistently for the entire 20-year lifespan of the turbine, but life's just not like that. In practical terms, the juice these mighty machines produce is really quite impressive. It's estimated that a single Haliade-X turbine in an offshore setting can generate enough power to supply 16,000 European households. A single full turn of the blades on GE's slightly upgraded 13-megawatt model is enough to supply 2 whole days of electricity for a typical UK household. Another way of looking at the benefits of wind power is emission reduction. Because they don't burn fossil fuels, obviously, the clean energy generated is the equivalent of taking 9,000 cars a year off the roads, or 42,000 metric tons of carbon emissions from the atmosphere. And again, that's just for one turbine. Did we mention they're pretty big? Well, they are, as tall as an 85-story building. And each of the Haliade's 3 individual windmill blades is 107 meters long. To put that into perspective, the wingspan of an Airbus A380 is only 80 meters. Being this swole isn't just some hollow clean energy flex, it actually makes sense from an engineering point of view. For one thing, installing great forests of these monsters on the seabed is no small undertaking, so the fewer you need to put there, the better, and cheaper it is for everyone. Those impressive blades, whose tips whir along at about 80 meters per second, cover a so-called swept area of 38,000 square meters. That's the size of 7 American football fields, by the way. And thanks to the way the area of a circle is worked out, pi times the radius squared, doubling the length of the blades can actually multiply this all-important swept zone by a factor of 4. Bigger in this case is clearly way better. Presently standing proud at Maasvlakte in the Dutch port of Rotterdam, the prototype proof-of-concept Haliade-X is an inspiring glimpse into the future. Perhaps its most striking early application will be on the vast new $10 billion Dogger Bank wind farm being developed to serve the UK market, 160 kilometres off the Yorkshire coast out in the North Sea. Dogger Bank will roll out in 3 stages, A, B and C. Phases A and B will collectively generate 2,400 megawatts from a remarkable 190 Haliade-X 13-megawatt offshore turbines, scheduled to deliver their first power to the grid as early as 2023. Once fully operational, around 2026, Dogger Bank will supply around 6 million UK homes, the equivalent of 5% of the whole country's energy consumption. Significantly, the final confirmation order for those 190 Haliade-X turbines landed on GE's desk the same day GE announced it would no longer be supplying power equipment to new coal-fired power plants. The green energy future is here. Offshore wind projects around the world are now lining up to order GE's looming behemoth. Energy giant Ørsted has ordered a raft of them for 2 of its projects off the east coast of the United States. Swedish utility firm Vattenfall also announced it will be deploying the 12-megawatt Haliade turbine for use on its Baltic and North Sea farms. In Brazil, the upcoming 702-megawatt Arsa branch project will likely make use of them, and in China, where wind energy is an even bigger deal than in the UK, a dedicated GE factory is being built purely to serve that key Asia-Pacific turbine market. It's just as well the orders are flowing in, because getting these turbines through development was no easy task for GE, which sunk a reported $400 million investment into the scheme. The essential safety certification, which proves they're worthy of real-world deployment, was only issued in November 2020, following a rigorous testing of the 12-megawatt Rotterdam prototype, with separate blades transported to both the UK's offshore renewable energy in Blyth, Northumberland, and the Massachusetts Wind Technology Testing Centre in Boston. As you'd expect, with such record-setting blades, building and transporting them is a formidable operation in itself, with specially built facilities custom-erected to do the job in Cherbourg, France. It's actually the first wind turbine blade ever to surpass 100 meters in length. 4 meters around at the root, made largely of fiberglass and cleverly engineered with a deliberate bend in order to prevent the blades flexing and striking the tower on especially breezy days. The pandemic presented its own challenges to the process, with the chief architects of the project forbidden to go to Blythe for the final static tests. I was able to guide the test team and monitor the tests by a live stream, lead engineer Cornelis van Beveren said in a recent interview. Streaming it across 3 monitors made my office desk feel like a kind of space launch environment. We weren't launching a rocket, but observing the blade pass extreme loads was just as exciting. As well as those massive blades, other innovations are also being tried for the first time on Haliade-X. Many of the ITS onboard diagnostic systems now work remotely. This is to avoid costly and dangerous seaborne maintenance missions, which can be especially treacherous on the North Sea. The engineering team also developed a brand new compact type of switchgear for the project. A switchgear, in case you don't already know, is akin to the fuse box in your house, just on a much grander scale. The switchgear helps energy flow seamlessly from the turbine to the power grid, but also halts that flow should a calamity occur like a lightning strike. At conventional onshore wind projects, these crucial switchgears occupy their own separate buildings, connected to the turbines via cables. However, at sea, that's not really an option, so engineers at GE set themselves the challenge of developing a switchgear powerful enough to function, but small enough to fit into the tower. The result is the so-called F35, which at 2.4 meters high and 3.7 meters long is an impressive 30% smaller than previous 66 kilovolt switchgears. One solution mooted to use a lower voltage switchgear, something in the 33 kilovolt range, but that would mitigate the benefits of such a large turbine and mean that less power would make it over to the land-based grid. As a happy offshoot of this project, the patented F35 switchgear can now be used on non-offshore and even non-wind farm applications. It can fit under a city building, for instance, which is a great space saver for architects and planners. It also uses a more environmentally conscious gas, G3, than the industry standard SF6 to cool and protect the switchgear process. To be sure, GE isn't the only company marketing colossal wind turbines right now. Danish manufacturer Vestas has a giant 15-megawatt beast ready for manufacture and trials. The company claims that on a 900-megawatt wind farm, their model would boost productivity by 5% and require 34 fewer turbines. So far, alas, none have actually been constructed. Siemens also has a 14-megawatt, the Gamesa, which it claims can be dialed up to a whopping 15 megawatts and even further than that with careful tinkering. A first prototype will be constructed in the autumn of 2021, but orders may flow in even before that. As one analyst memorably put it, clean energy investors are quite happy to invest in so-called green bananas, projects that aren't quite ready yet if it means they can get an edge on the competition. Either way, these mammoth offshore turbines are one form of green tech that clearly has the wind at its back right now.